Okay, this is the second vodcast for Unit 11 on solutions, calculating concentrations. You are going to want a calculator and a periodic table handy for this one. So the concentration of a solution is, let's back up there. So the concentration of a solution is the measure of the amount of solute dissolved in a solution. So remember, you have two parts to a solution. You have the solute dissolved in the solvent. And together the solute plus the solvent make the solution. A dilute solution has a low concentration of solute, typically in a large concentration of solvent, in a lot of solvent there. A concentrated solution has a high concentration of solute, so you have a lot of solute in your solvent. So if you think about if you've ever, from the freezer section, made orange juice or lemonade or fruit punch or something from concentrate, this is that same thing. Okay, that's a concentrated solution. And then you add water and make a dilute solution to something that is more enjoyable to drink. So here's a picture showing a concentrated solution versus a dilute solution. The blue particles are your solute, and then the purple one's the solvent. And so here in the concentrated solution, we've got a lot of blue particles showing, but in the dilute solution, only a few compared to the other one. Okay, so there's not as many solute particles amongst all the solvent. And I think what they're also trying to show you in this one too is that there's a change in blue color. The dilute solution is less blue, but it's tougher to see in this picture. Now, we can compare solutions and express concentration using two different things, either molarity or percent solution. It's fine to say dilute versus concentrated, but that's more of a qualitative definition, and we want quantitative ones dealing with quantities. So chemists like to calculate concentration using molarity, and biologists do it more with percentages, but you're going to need to know how to do both. So, molarity is the number of moles of a solute dissolved per liter of solution. That's the definition of molarity. Molarity is abbreviated with a capital italicized M. So I just normally make a capital M. Here's the formula for molarity. It's the moles of solute divided by liters of solution. Or the easier way to write it is molarity equals moles divided by liters. Okay, so that's your formula there. Unfortunately, this formula is not provided on the back of the periodic table, and so it's just one you're going to have to learn. Fortunately, it's pretty easy. Once you do a number of these problems, you'll have it down. So here's our first example. Let's clean up this writing here. Okay, you have 2 moles of glucose dissolved in 5 liters of solution. So moles divided by liters. Well, here's my moles. 2 moles divided by 5 liters of solution. And I calculate that out, and it's 0.4 molarity. Or we would say this is a 0.4 molar solution. So that's as easy as molarity can be. You just take the moles, divide it by the liters. Now, of course, our scales don't measure in moles, they measure in grams. So what you're going to have to do sometimes is turn grams into moles, and sometimes you're going to have to turn milliliters into liters. So a saline solution contains 0.90 grams of NaCl in exactly 0.100 liters of solution. What's the molarity? So I have to change this to moles. And then this one here is okay, it's already in liters. So to change things into moles, question mark moles over the grams that I'm given, 0.90 grams of NaCl. Okay, carry the units over, moles, grams. Moles is always a 1, and then grams we add up off the periodic table, and let's do that real quick. Sodium's 22.99, chlorine 35.45. We add those up, 58.44. Cross multiply, 0.9 divided by 58.44, and you get 0.015 moles. Okay. Well, at this point now, all I have to do is, since I have moles, divided by my liters, 0.100 liters. And my answer then is 0.15 molarity. Okay, so again, sometimes you're going to have to change moles into liters. Sometimes, moles into grams into moles. Let's try that again. Sometimes you're going to have to change grams into moles. All right, doing what we did above, and milliliters to liters. And milliliters to liters, you divide by 1,000, which is the same as moving the decimal 3 times. So that's all there is to molarity. Of course, sometimes you're going to be asked to figure out the moles or the liters on your worksheet. The first side of the worksheet that goes with this lecture is all about calculating molarity. Okay, for percentage of solutions, you have 3 types of percentages you need to know how to do. Fortunately, they all work the same. The first one is mass percent, which is mass divided by mass, then volume percent, V divided by V, and then mass by volume percent. Now, percentages all work the same. It's the part you want, right, over the whole thing times 100. Okay, that's going to get you a percent, no matter what class you're in, chemistry, math, sales shopping. Okay, so the part you're looking for, or the part you want, divided by the whole thing times 100 will give you the percentage. So the question here, what is the mass percent of a solution that is 76 grams of sugar in 524 grams of water? So we want to know what percentage of this is sugar. So the part we're looking for is 76 grams divided by the whole thing. Well, the whole thing is these 2 things added together. If I add those 2 things together, it's 600 grams. Okay, this is the trickiest thing about these problems is reading them close enough to know exactly what they're asking. Sometimes you're going to have to add the things together like we just did. Other times you won't. Now we've got 12 point and it's a repeating 6, so when I round for sig figs there, it becomes 13%. And this is a 13% sugar solution. And that's your answer. Volume percent's going to work the same way. We read the question closely. What is the percent by volume of ethanol in the final solution when 85 milliliters of ethanol is diluted to a volume of 250 milliliters with water? So here I've got my beaker, okay, and here I have 85 milliliters of ethanol. And then it says it's diluted, so this is my ethanol. Then it says it's diluted to 250 milliliters with water. So now I'm at 250 milliliters with H2O. So I'm looking for the percentage of ethanol. So that's 85 milliliters divided by my total solution. Well, my total solution is 250 milliliters in this case. This is the final volume right here. And then times 100. For this one, we didn't have to actually add. Like I said, if you take a look at the wording real closely, you'll see that you didn't have to add those 2 volumes together. So in this case, the answer works out to 34%. So it worked out exactly the same way. You just have to watch the wording for what the total volume or total mass of the solution is. For mass per volume percent, you don't have to worry about whether or not you add something, okay? This here tells you exactly what you're going to do. You are going to do mass divided by volume. So a solution contains 2.7 grams of copper 2 sulfate. Well, there's my mass divided by my volume of solution, 75 milliliters times 100. Okay, that's all there is to these here. And we calculate that out, and it works out to 3.6%. Okay, so the percentages are pretty easy once you learn how the pattern works. Probably the toughest thing is just figuring out what your whole is, whether or not you add things together or not. So on the back side of your worksheet, the first chunk questions are these percentage type questions. The last type of questions involve dilution of solutions. So sometimes we have a solution, but it is not the concentration we are looking for. Okay, so we can take a more concentrated solution and make a dilution by using more solvent. This is what you do when you buy those frozen juice concentrates at the store. You take the concentrate, you defrost it, put it in a container, and then you add water. You dilute it to the concentration you like to drink it at. So what happens is the dilution reduces the moles of solute per unit of volume. And here's your formula. M1 times V1 equals M2 times V2. Or simply, we just write M1 V1 equals M2 V2. Now hopefully this looks familiar to you. This probably looks similar to the pressure equation, and it solves the same way. Okay, it does not matter what our volume is. It can be milliliters or liters. Okay, so it doesn't matter. And then of course the M stands for molarity. So how many milliliters of a stock solution of 2 molar magnesium sulfate would you need to prepare 100 milliliters of 0.4 molar magnesium sulfate? Now stock solution just means that's what I have in the stock room. Okay, if we're talking about the concentrated stuff you buy at the grocery store, that would be your stock solution. So this is telling me I have 2 molar magnesium sulfate. What would you need to prepare 100 milliliter of 0.4 molar? Now this is just like those gas problems. Make a list, and it doesn't matter what you call 1 or 2, just as long as you keep them paired up together. So the question is, how many milliliters? Okay, well, milliliters is a volume, so let's just say our question mark is V1. Of a stock solution of 2 molar magnesium sulfate, so 2.00 molar, would you need to prepare 100 milliliters, here's my V2, of 0.400 molar magnesium sulfate. So I have M1 V1 equals M2 V2. I am looking for V1, so I need to divide by M1 so I can get V1 all by itself. And so V1 is equal to M2, 0.400 molar, V2, 100 milliliters, divided by my M1, 2.00 moles. Okay, and if we multiply this out, what you get is 20, and if we do the sig figs, we want 3 sig figs, 20.0 milliliters. Molarities canceled out, so I'm left with milliliters then. And that's all there is to dilution. And those are the last 3 problems there on your 3 or 4 problems that on your worksheet. Okay, the stock solutions that you need are in the intro to that section, so be sure you read it closely. Okay, so that's it. So that falls under solute and solvent. We can calculate the concentrations, okay, using molarity or mass percentages.